Hello and welcome to another tutorial. In this tutorial, I'm going to continue the discussion on native image, and we're going to look at a very important discussion, which is how to design our Java application and later compile it to native executable binary, and in such a way that our application is a command line application and it accepts some command line arguments. And you know that whenever you have some command line application, usually it accepts flags with hyphen some word or hyphen some letter. For example, if I open up a basically a terminal here and then say, for example, Java and then hyphen version, right? So this is a command line argument, and it doesn't accept any parameter for this particular arguments, right? So if we say Java hyphen version, this application, which is Java, which is a binary application, understands this flag. And then if we say Java hyphen help, it lists all the flags, right, that this Java application accepts. And some of the flags start with hyphen and a single letter. Some of the one start with hyphen and usually abbreviations, for example, hyphen CP or hyphen class path. If we want to introduce a hyphen in between the name of the flag, we normally use two hyphens, hyphen and then class hyphen path, or single hyphen CP or single hyphen class path. So usually single hyphen is used with letters and abbreviations, and hyphen is used with the words that have more than one part. So module dash path or hyphen path, we use hyphen, right? So hyphen dry hyphen run or hyphen. So this is the convention. You don't have to necessarily follow this, but that's a good practice to follow this convention. For example, instead of saying Java hyphen help, we can say Java hyphen h. That's also the abbreviation. So you can either use hyphen help or hyphen h, right? So this is how we can set up our basically command line arguments. So now you can do the same thing even with the Java application, which runs on the JVM. So command line arguments are passed to the Java application during the launch of the JVM, and we've seen this before, that's the string array args that the main method has, right? JVM knows which class has the main method, and the main method accepts a array of strings, right? If you don't specify any arguments after the name of the main class on the command line when you run the JVM, then it means the string array args is empty. There is nothing there, right? We can use a command line parser framework that already is available. Now the question basically is, when somebody passes command line arguments, right, to the Java application, how do we grab those and transform them into the objects? Remember, your Java code, Java is object oriented, so we have to kind of transform those command lines into objects, or create objects, set some of the fields or properties of those objects based on the command line arguments. Now the naive thing to do is to write if else statements or a switch statement and go through all the strings in that string array args, and we manually write the parser. Somehow we manually write the logic down, and then based on the command lines we decide what kind of objects to create. And that's possible, but nobody does that, right? It's better to stick with a framework that has already been tested, and it provides a lot of nice and flexible features. Now the framework that I recommend is called JCommander. The source code is on the GitHub. You can just go to github.com/cbeust and then JCommander. And then the online documentation is jcommander.org. It has a very, very nice documentation. That's also one of the reasons that I'm recommending this framework, because its documentation is very nice. It's also available on Maven, Gradle, or any other build tool that you use. I personally use Maven. It's very easy. The group ID is com.beust. Artifact ID is JCommander, and the version, you can just set it as the latest version. As of today, it's 1.82. And basically the way this works is that you create empty objects and then you pass them, and the JCommander has a static builder pattern which uses reflection to build the objects, or basically it doesn't call the constructor. You create empty objects and then you pass it to the JCommander, you pass the command line arguments, and the commander sets the fields or the state of those objects using reflection. It has a parse method to parse the string array args. It uses reflection to accomplish parsing. And then obviously the first question that you're going to ask is, how does it know which fields to parse or set values based on the command line arguments? And it provides a very nice annotation feature, which I will show you. But first, let's look at the features. Why am I recommending this JCommander? Obviously, one of them is it has very nice documentation, very detailed, very nice examples, but it's very easy and intuitive to use. All complexity is hidden from the user. You literally don't need to do anything. It can parse multiple objects at the same time. Let's say based on the command line arguments, you want to parse multiple objects. Parameters that are not set on the command line get default values. That's one of the nice features. And I believe most of the frameworks that work in different programming languages like Python, C++, or this one in Java, they have this feature that what if you have lots of parameters, but somebody doesn't provide some values for some of the parameters. So it makes sense that to design this framework for parsing command line in such a way that if one of the parameters is not set on the command line, it gets a default value, right? Each Java field can get multiple names on the command line. As I mentioned, for example, Java, we can use either -help or -h, right? That's usually the convention we use. And both of these, -help and -h, they do the same thing. So they map to the same command, right? It has a rich online documentation, as I mentioned, and it works with Java collections as well, which means you can even set a flag on the command line to say and give multiple values, and then internally the JCommander can map all those values and build a list, array list or a set or something, which is the field of an object. Now, a very simple example is here. First of all, as I mentioned, the builder pattern that the JCommander follows, it doesn't really directly call any constructor, so you kind of use it mainly for data classes or POJOs, plain old Java objects. So you just want to set some fields, right? So you create an empty object and then basically pass it to the JCommander, and it parses the command line arguments and then sets the values of the fields, right? So create a class with an int field called value. And then I'm going to assign it 2 command line flags for setting up this value. The user can either give -v and then a space and then the value, or -value. I want both these commands or flags to map to basically parse to set this int field called value in an object. So the first thing you do, obviously you add your JCommander to the build path. I will use Maven, so it's very easy. You just add the Maven coordinates, the dependency to your POM file, and after that you create your class as usual. But then you annotate it with add parameter. This is the nice annotation that the JCommander framework provides, and then it has a list or array of strings called names, and then you can directly initialize it in with this nice syntax, right? So this is an array of string. You can provide as many strings as you want or as many flags as you want so that they all map to the same field, right? Step 2, create an empty object. I called my class test class. It has an empty or default constructor which doesn't do anything. So you have to create this object, and then you use the JCommander, get the builder, add object, and obviously you can add multiple objects, that's fine. And then you call the build, and then when you call the build, it uses the reflection to basically figure out what fields have been annotated, etc. So this build is mandatory, and after that parse, and you pass the string array args of the main method to it. And then after that, it already has figured out which fields have been annotated. So it goes through the string array args and then maps all those command line or all those flags to set the right values, right? And then once after that, if we say object.value, this object, you will see that it's been properly set. So, and then obviously we're going to run our Java application on top of the JVM first to make sure everything works fine. And then we'll figure out how to compile our Java application with this capability into a native executable binary, so that when we launch that native binary, all these flags are still available. We've already seen that how to include dependencies, because right now, in order to use this framework, our Java application is going to have a dependency, which is the JCommander. We've gone into details how to work with Maven when we want to compile to native executable, how to handle dependencies, and Eclipse IDE basically takes care of everything. So let's head to Eclipse and try to go through this example and have a good understanding of what's going on. So here's Eclipse. I have this Maven project, and in my POM file, if you look at the dependencies, I've already added the JCommander version 1.82. You just basically copy and paste this one, right? JCommander. And after that, Maven grabs the repository com.buse. And then in the JCommander, we have converters, default provider, internals, parcel, validators, and lots of classes, right? For integer, parsing strings, other parameters. This is the main annotation that we use. Parameter, a string array names, and then a string. You can also add description, whether it's required or not. And this means that it has to, if you set it to be required, means that the user has to set it as a flag on the command line. It's not possible to give it a default value. Description key, default array, or default arity is -1. Arity means usually you have one, which means when you set the flag, you only pass one parameter, or you can set it to have multiple values, whether it's a password or not. And then you can also define your own converters, how to convert the string that is passed to the command line to the actual value of the field, and then a lot of other capabilities. I will have a full course on JCommander to go into the details, but for now, we're just going to start with a very simple example. All right, so we have this test class. It has a field int value, and I want to parse these arguments such that essentially the user provides a flag, let's say. So I want the user to provide -- value and some value, let's say 10, or -v and some value, like 20, right? Usually there's at least one space here. Multiple spaces are fine. It's not going to break the code. But for now, I want to do this, right? So first, the very first thing that I do is create a test class here, right? And then if I do a sysout on object.value, obviously it gets the default value because it hasn't been initialized. JVM will initialize it to 0. So if I run this, I will get 0, right? And I'm printing this one also. So I will get 0. And then if I want to run this using Eclipse and pass command line arguments, so what I need to do is go here and here --value 10, right? So if I run this, I still don't get, because right now I'm not parsing it. So what I can do manually is say basically I can write a for loop for int, for example, I = 0, I less than args.length, I ++. I can say if basically if args at index I equals -- value, or args at index I equals actually this should be double quote, not a single quote, -- value, or args at index I is -v. Then we're going to say that object.value equals basically integer dot parse int, and then args at index I +1, right? So and then let's run this, and now we still get 0. Okay, let's see, let's run this. Let's go back to our run configuration. --value 10, we're running this. So let's do a sysout on the args. So let's see. Let's see what kind of command line arguments are passed. A string array. Maybe we also print this. So sysout args at index I. So we have --value and 10. So actually we shouldn't use double equality equals this one, or args equals hyphen hyphen v. So for string equality, we have to use equals, and now we get 10, right? So this is how you can manually parse this array. You have to kind of loop through this, and then you write a general for loop, and then you write a lot of if else statements to figure out at index I which flags are passed, and then once you find a flag, then you can figure out what to do. You want to parse it or somehow convert it to some sort of integer value or some other things, right? So run this, and then this works fine. But this is tedious, and as if you have many objects, this for loop and if else statements can become very long. So we don't want to do this. So then the question, how do we do that? We're going to use a framework, right? So use a JCommander framework. So we are creating our empty object, and we want to set its field. The very first thing that we're going to do this, we're going to annotate it with add parameter. And we're going to use the names, which is a string array, and then we're going to initialize it with the flags, hyphen hyphen value or hyphen v, right? And then that's it. That's all it takes. And then here we're just going to say that JCommander new builder. So JCommander already only has this new builder, which uses the inner class builder that the JCommander has. And after this, we're going to say that basically add object, and we're going to add our obj class. So we are only going to build one object from this string args, and then after that we're going to build. It returns the builder, right? So the new builder builder, and then add object returns the builder, and then build returns the JCommander. So basically this is a fluent builder interface. And then after we build it, we just tell it now go ahead and parse it, args, right? That's it. And so until this build, the builder goes through all the objects that we add, and then figures out which ones have this annotation so that it knows which parameters to parse. And after that you tell it now go ahead and parse it. So it loops. Basically it's more or less the same idea, it's just hidden from you. So if we run this, we still get 10, right? And if I go ahead and change this to, let's say, -25 and run it, I get -25. So everything is working fine. JCommander is a very nice syntax. You don't need to manually do any. And if I add a new parameter, let's say double basically some basically let's say double x, right? And all I have to do, I can do add parameter and then names, and then let's say hyphen x. So if I go ahead and basically, so object x, if I run this right now, we're not setting it, so it gets the default value that the JVM sets, but we can also give it a default, right? So description, hidden, order, password requires if you look at the parameter again, it has description, arity, converter, hidden, echo input, help. It does have the help, right? If true, this parameter is for help. If such a parameter is specified, required parameters are no longer checked for their presence, and order, right? So these are all the details. So we set this with the hyphen x, and then pretty much we don't do anything else. That's it. You don't. So if you manually write your own for loop, then if you add more parameters for parsing, you have to go ahead and add more lines of code for if else statement and check for the flags. Whereas in JCommander, you just add this annotation. Your code doesn't change. So if I go ahead and in the arguments say hyphen x is 2.5 and then run it, and my x now gets 2.5. It's very easy to use. All right. So then the question is, now we're using this, how do we go about and converting it or compiling it to native executable binary? So if I try to select this and run my native image, if I compile this, this is most likely not going to work. The reason is that we've said this before. Right now, the native compiler doesn't know what's going on behind the scenes in the J commander. We know that this uses reflection to figure out. So let's see what error was given. So it's pretty much giving us error that there are some reflections going on, which I don't know about. So it tries to do a fallback. Now it tries to do a fallback as a wrapper, right? So so it uses reflection to figure out the annotations, and then after that it uses reflection again to set up basically the values, right? All the parameters, to access the parameters of all the objects that we register. Now if I open up a terminal here, the native image is already telling me it's a fallback, which requires a JDK for execution. So if I try to run the binary test class with, let's say, -- value 25, could not find or load. So we know that when the fallback happens, we can't really run this. So let's delete this. So what's the solution? We know we've already seen how to deal with reflection. We have to tell NativeImage and create those configuration files. And the way we do it, we run our application with the Java trace, right? But then because our application accepts command-line arguments, we kind of need to go here. So we are running the Java or JVM from the GraalVM and activating the agent lib for the native image. And we are manually setting the class path. And then Java type name, this is our main class. And we're passing some parameters. Let's say -- value 10 and -- x 2.5. So you only need to do this once because the tracing agent needs to know, and you don't really need to pass all of them. Let's say let's only pass value, and we will see that basically the compilation will work, right? So so let's run this on our test class. Right now we didn't pass any value for x, so it sets to the default. And if you look at the meta-inf native image and then reflect config, you see that a lot of the J commander classes are registered, and then we have a name int, and then Java, and then our main class is also registered for reflection. So now if we go ahead and compile to native executable, remember the meta-inf is our is on the class path of the native image that we use, right? So it's going to pick up on the meta-inf. So let's close this, select our class, and then run our native image. So it will automatically pick up on this meta-inf and this reflection config, and hopefully it's going to work fine. So let's wait for it to finish compilation. Note that what we needed to do was to also pass some command line arguments, because if you don't pass, when you run the Java tracing agent, we know that reflections happen in two places, one at the time of the build and the other one at the time of parsing. So when we run our Java trace agent, if we don't pass any command line arguments, we don't get all the configurations. So let's open up a terminal here. So let's say -- value 25, it works fine. X gets the default value 0, and then -- x 2.5. And this doesn't work, right? So the reason this doesn't work because we didn't register this -- x. So you really have to run this with all the parameters, and then so that in the configuration we know everything about it. So let's go back and terminate. So I'm going to delete the meta-inf. And then I'm going to also delete this binary. And now what I'm going to do, I'm going to run my Java trace agent, but then also add -- x, let's say minus 11.5, something to invoke this reflection that happens for the x as well. So let's run this, and everything works fine. And now if we look at the meta-inf and then reflect config, we have two reflection fields. One is double. the other one is int, right? So you have to register all these fields. A little bit tedious, it kind of defeats the purpose. But if you just want to run your application on top of JVM, obviously you don't care, it's very easy. But if you want to compile to native executable, you have to tell a native compiler about all these parameters and that use reflection, and for that you have to run your application with a Java trace agent at least one time, and then pass all the flags that your application will accept, so that that configuration file, the reflect config, picks up on all the parameters that will be set or can be set on the command line. So if we now select our class and then run our native image, this time everything should work fine. We accept only two command line parameters, --, value or -v equivalently, and then --, x. And then the native image has information about all these two parameters. So let's wait until this finishes up, and then we will test the result. Almost done. So let's open a terminal here, and then let's run this. So -value 25 -x 2.5, everything works fine. We don't get any exception now for x, because it was already in the configuration file for reflection. The other thing is, now we can also test the other option, -v. Still works fine, right? If we pass a different flag, let's say -p, it's not going to work, so we get an exception, but no main parameter was defined in your R class, right? So that's kind of exception happens. I believe we can configure it to kind of ignore that flag, but for now. And the other thing that you might already know, that the order of the flags don't matter, -x. If we don't pass it, we get 0. We can set the required flag. So if here we say that required equal true, then we go ahead and compile. We already have the basically meta inf, so we just go ahead and compile quickly. Let's see what happens if we set the required to true, but then we don't pass this flag at the time we run our binary file. Almost done. All right, done. Let's refresh this. We get the binary. Let's open up our terminal, and now let's see what happens if we don't set it. Exception, the following option is required, --, value or -v. Now it says that you have to pass it. So we have to say -v 12. It works. But if we pass a float, it's going to give us exception saying that couldn't convert 12.5 to an integer. So what's it's saying that you have to make sure that this is all set, right? So I hope you enjoyed this lecture and now have a good understanding how to easily use this JCommander framework to set up flags for your Java application, and then what to do when you want to compile it to native executable binary. You have to run it with the JVM using the tracing agent, so that you create the configuration file for all the reflections that happen in the JCommander, and then the rest is very easy. You just compile your application and all the flags stay the same. I hope you enjoyed this lecture. Please stay tuned, and I'll see you in the next one.